Hey everybody, we're back. Now we're looking at biochemistry. Let's jump on in. If you've survived this far, you should be in good shape. So, several definitions of biochemistry. Study of chemistry of living systems, study of structure, organization, interaction of substances with living matter, blah, 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 blah. Okay? Know those. Okay? Know those. Biochemistry has two AKAs, biological chemistry and physiological chemistry. So the first big one we're looking at are carbs. Carbohydrates are defined as derivatives of polyhydric alcohols containing an aldehyde or a ketone group. They can also be defined as the result of the oxidation of polyhydroxy alcohols. Now, before anyone starts crying, we're looking at straight definitions, okay? A derivative of polyhydric alcohol containing an aldehyde or a ketone group is known as BINC. That's it, okay? That's all that is. As a class of compounds, carbohydrates includes sugars, starches, cellulose, and glycogen. And carbohydrates are often named using the suffix OSE, glucose, fructose, sucrose, okay? Those carbohydrates containing an aldehyde functional group are called aldoses. That would be important. Those with a ketone group are called ketoses. Carbohydrates are composed of only three elements: carbon, hydrogen, and oxygen. Nothing more. Carbohydrates can range from relatively simple compounds to those which are quite complex. The simplest of the carbohydrates, the simple sugars, these are monosaccharides, okay? The simple sugars may have from 3 to 7 carbons in their structure. Because the number of carbons is important, they may be grouped according to this number. So 3 carbons, trios, tetros, pentos, hexos. These prefixes should be familiar because they are pretty much copy-pasted right out of the alkane chapter, okay? The monosaccharides of greatest significance to the body are the hexose monosaccharides. They have the molecular formula C6H12O6. Hexose monosaccharides are an excellent source of energy for the body, providing about 4 calories per gram. And glucose, fructose, and galactose are the ones we're going to discuss. Glucose is an aldose, has several names: dextrose, grape sugar, blood sugar. And its importance is its presence in the blood. People with diabetes must monitor their insulin and glucose levels so they don't run into a negative health reaction. Fructose is a ketose. It is the sweetest of the sugars, almost twice as sweet as table sugar. Fructose is also known as levulose and fruit sugar. Honey is about 80% fructose and glucose. The remainder is water and a few other ingredients. So this should give you an idea of why honey is as sweet as it is. Galactose is another important aldose, important to the body because it is found in the makeup of the brain and nerve tissue. It is derived from lactose or milk sugar. Disaccharides and carbohydrates containing 2 saccharide groups, okay? Disaccharide, monosaccharide, 1, 2. Disaccharides are carbs containing 2 saccharide groups. Disaccharides, derived from the hexose monosaccharides, will all have the molecular formula C12H22O11. This is basically equivalent of dehydrating between 2 monosaccharides. You're going to see that here in a second. There it is. You can derive the molecular formula by adding the formulas for 2 monosaccharides and then subtracting the formula for water, which allows them to combine. The disaccharides, which contain the hexose monosaccharides discussed above, are sucrose, maltose, and lactose. Sucrose is table sugar, cane sugar. It's formed from the dehydration between a molecule of glucose and a molecule of fructose. Sucrose may be hydrolyzed to yield glucose and fructose. So it's not hard. All it's saying is if it's made up of glucose and fructose, if I decompose it, hydrolyze it, it's going to go to its component elements, or in this case, component compounds. Maltose. Maltose is malt sugar. It is formed by dehydrating between two glucose molecules. Maltose may be hydrolyzed to yield 2 molecules of glucose. And lactose is milk sugar, formed by dehydrating between a molecule of glucose and a molecule of galactose. Lactose may be hydrolyzed to yield glucose and galactose. So every one of these disaccharides should have a little column as to what makes them up. Okay? You should know which two added together create what they are. Polysaccharides are complex sugars which will have many saccharide groups. Okay? So here you have an idea of what that is. So there's the monosaccharide. Okay? We then get the disaccharide and then polysaccharide. Just a bunch of them in a chain. More than 2. Polysaccharides include starches, cellulose, and glycogen. They may be hydrolyzed repeatedly, okay, to eventually yield monosaccharides. Obviously, a monosaccharide cannot be further hydrolyzed. If you break it down any further, it starts going into its constituent element parts rather than being a monosaccharide. Starches occur in plants such as tubers and grains, and starches are the most important polysaccharides to humans. Complete hydrolysis of a starch yields monosaccharides. Well, go figure. We just said that if we take a polysaccharide, a bunch of monosaccharides all added up in a chain or a circle or whatever, and start breaking them down, we'll go from poly down to a di, and then if we keep doing it from a di to a mono, once we get to the mono, we're done. Glycogen occurs as a stored polysaccharide in the liver of humans and other animals. The buildup of glycogen is important because this is how our bodies store sugar for later use. Cellulose occurs in the makeup of many plants. It is not digestible by the human digestive tract, so it serves only as a bulking agent in our diets. If you're not getting enough fiber, you are not getting enough cellulose. Says the hydrolytic products of carbohydrates are ultimately the monosaccharides. Again, no matter how complex the carbohydrate gets, at the end of the day, it's built up of monosaccharides. So if you're going to decompose it to its roots, it's going to go back always to a monosaccharide. And understand, we're not talking about just adding water to the sugar and watching it break down, okay? This is a bit more complex. So besides the addition of water, you need a specific type of enzyme. So the oxidation of carbohydrates, if you were to break them down, ultimately yields carbon dioxide in water. Oxidation of carbohydrates is also referred to as animal metabolism of carbohydrates. This metabolism process is the body's chief source of energy. It is the opposite of the photosynthesis reaction that occurs in plants. Photosynthesis is the process by which plants convert carbon dioxide, water, and solar energy into carbohydrates and oxygen while in the presence of a catalyst, in this case chlorophyll. It is the exact opposite of the oxidation of a simple sugar. Fermentation has several definitions. The anaerobic breakdown of organic compounds, in this case carbohydrates, by microorganisms into simpler products, releasing carbon dioxide. And the oxidative decomposition of complex substances through the action of enzymes produced by microorganisms. In the embalming textbook, this definition is simplified down to the breakdown of carbohydrates by anaerobic bacteria. So, once again, you're being called to memorize 3 definitions for the same thing. Considering that embalming has like 7 definitions, we're not asking too much here. Fermentation is the reaction often associated with the fermentation of glucose in the presence of an enzyme mixture, zymase, which is found in yeast to produce ethanol. Fermentation is the foundation of all bad decisions in the phrase, hold my beer. Lipids are substances able to yield fatty acids when hydrolyzed. They are made with alcohol combined with a fatty acid. Technically, lipids are types of esters. The name lipid comes from a Greek word which means fat. The word fat refers to only a certain class of lipid rather than all lipids. All lipids must have the same elements present as in a carbohydrate, but also have other elements which may be present, such as nitrogen and phosphorus. As a group, the lipids are very different. One of the few similarities the lipids have in common is that they are generally insoluble in water, but they are soluble in organic solvents such as some alcohols, some ethers, acetone, benzene, chloroform, and carbon tet. A simple lipid is an ester of fatty acids. Fats and oils are simple lipids which, once hydrolyzed, will yield fatty acids and a glycerol. Fats and oils can be described as glycerol esters of fatty acids, or esters of glycerol and fatty acids, sometimes just called glycerides. Why don't they just always call it glycerides? Recall that an ester is derived from an alcohol and organic acid. Each molecule of a fat or an oil may be hydrolyzed to yield a single glycerin and up to 3 fatty acids. There are 2 major categories: simple glycerides and mixed glycerides. Glycerides in which all the fatty acids are the same are simple glycerides because they're all the same. Those glycerides containing more than one type of fatty acid are then mixed glycerides. Those glycerides containing only one molecule of fatty acid are called monoglycerides or monoisocycloglycerols. 2 molecules equals diglycerides, 3 molecules triglycerides, etc., etc., etc. The distinction between a fat or an oil is determined by the characteristics of the fatty acid they contain. If the fatty acids are saturated, then the glyceride is a fat. Fats tend to be solid at room temperatures. If they're unsaturated, it's an oil, and they tend to be liquids. It's right in the names. An oil tends to be a liquid at room temp. Fats are usually solids. Stearin, or tristearin, is an example of a fat. It contains the fatty acid stearic acid, which has a relatively high molecular weight and is saturated. Both stearic acid and palmitic acid are saturated acids. Oils containing the unsaturated fatty acids, oleic acid or linoleic acid, will be liquid at room temperatures. The more unsaturated the fatty acid, the lower the molecule's melting point, which causes many to be liquids at room temperature. Go figure. Fatty acids go by the general formula Rx-COOH. If the Rx is saturated, again, it's going to be a solid. If the Rx is unsaturated, it's going to be a liquid. Fats are very important to the human body. They are superior to carbohydrates as a source of energy in that they yield 9 calories per gram as compared to 4 calories per gram of a carbohydrate. The body is able to store fats in unlimited quantities. Fats serve to prevent dehydration of body cells as well as to insulate the body in terms of heat retention, and even serve to cushion certain body organs. The oxidation of a fat or an oil results in the end products carbon dioxide, water, and a release of energy. When hydrolyzed, a fat or oil results in end products glycerol and fatty acids. Saponification is defined as the alkaline hydrolysis of a fat or an oil to produce a soap and a glycerol. The alkaline substance may be a base, such as lye. When sodium hydroxide is used, the end products are glycerin and lye soap. Grave wax, also known as adipocere, is a result of the saponification of fatty acids in the dead human body by alkaline substances in the water or the earth surrounding the grave. Grave wax is usually associated with the body that has been immersed in water for a period of time or is buried in a damp grave. The appearance of grave wax is not very frequent due to the use of protective caskets and vaults. A soap is defined as the substance, besides glycerol, produced when saponification of a fat or oil occurs. The anion of the base has become a part of what would have been the fatty acid to form the soap. Soaps are very important because they are used to make emulsions. We've seen that an emulsion is a mixture of two liquids which do not ordinarily mix, such as water and oil, to which you add soap, which causes them to mix. That's the reason why we wash with soaps, because the soap isolates the individual particles of oil on the surface of the skin containing dirt and allows these particles to be removed by mechanically washing the surface of the skin. Emulsification refers to the process of creating an emulsion by adding a soap. In the digestive tract of the human body, bile serves as an emulsifier to allow the absorption of the fats in our diet. Waxes are lipids that are esters of fatty acids and high molecular weight alcohols other than glycerol. The more common waxes are beeswax, lanolin, spermaceti, and carnauba wax. Lanolin and spermaceti are significant to cosmetologists because they are used in creams, lotions, and cosmetics. Do not confuse paraffin with true waxes. Paraffin does not contain an ester. A mixed or compound lipid is one which, when hydrolyzed, will yield fatty acids and alcohol and some other compound. Phospholipids and glycolipids, two important compounds found in the tissues of the brain, are in this category. Folks, thank you for your attention. We will see you next time.